X equals the opposite of b plus or minus the square root of b squared minus 4c all over 2a. That's right. Part 5 is going to be the quadratic formula. So welcome to part 5 of the quadratic series. What we're going to do is solve this using the quadratic formula. And hopefully you know that you can sing Pop Goes the Weasel to this. So there's something important. We're not just doing direct substitution here. Let's talk about the discriminant, because we're going to need to find it anyway. So if we find a discriminant, there's some cool things that happen here. If your discriminant is greater than 0, then there exists two real solutions. If your discriminant equals 0, there exists only one solution because you get plus or minus nothing. And if your discriminant is less than 0, then there exist two non-real solutions. Because you cannot take the square root of a negative number. You can get a complex solution though if you want to, but we're going to skip that conversation for right now. If you want to, it could even be imaginary, but cool. So, important thing is I have my quadratic equal to 0. My quadratic needs to be equal to 0 to do this, because I'm trying to solve for the zeros or the x-intercepts or the roots. A equals 2, b equals negative 4, and c equals 12. Let's find that all-important discriminant. So b squared minus 4ac, I do some substitution. My b is negative 11, minus 4 times 2 times 12. Negative 11 squared is 121. The product of this is 96. Subtract these, you get 25. Since the discriminant is greater than 0, there are two real solutions. So now that I find the discriminant, let's substitute that along with everything else back into the quadratic formula. Cool. So we get x equals the opposite of negative 11 plus or minus the square root of 25 all over 2 times 2. If we go back to the quadratic formula, this isn't negative b, because this is already technically negative. This is the opposite of b. So the opposite of negative 11 is plus 11. The square root of 25 is 5. And then it's all over 4. And then, wow, deja vu again. We get x equals 11 plus or minus 5 over 4. So we get 11 minus 5 over 4, and 11 plus 5 over 4. And we combine, we simplify this out. We get 6 fourths, which goes to 3 halves. We get 16 fourths, which goes to 4. So notice, pretty easy to do. But I do suggest finding that discriminant in order to determine how many solutions you could potentially have. Because if you're looking for real solutions and your discriminant is negative, you know there are not going to be any real solutions. Cool. Have fun.